And now for another different approach to semantics, Amit.
All right. I'll more pick up on what we discussed in the previous session than the earlier talks of this session. I'll talk about citizen sensing and a lot of things about social data and the role of semantics in making sense out of social data. Should this work?
Oh, sorry, it's the white one.
The white one. Okay. This should, okay. So very briefly, where I come from and what we do at the Kno.e.sis Center, Ohio Center of Excellence in Knowledge and Computing, we apply semantics at various levels or for different issues. Cloud interoperability, web services and semantic web services, to social computing, which is what this talk will focus on knowledge discovery from biomedical and other texts. And ultimately, the goal is that of what I call computing for human experience. So you may think about at this conference or meeting, there's a lot of discussion of NUI, next generation of user interfaces. There has been earlier work on ubiquitous computing. But ultimately, what matters is the intelligence behind in the system. And so I'm more interested in how the system works to improve the human experience, to improve human decision making. So it does not matter how I interact with the computer, but or even if I can interact very naturally with the computer, or what will matter is how there is an understanding of that particular gesture anyway, that's the broader field. I'll step back in 10 years. In 1999, I started a company, and the topic about what we worked on, the company was about semantic web and its application in browsing, searching, profiling, personalization, advertisement. And this is probably one of the figures from the patent application granted in 2000, 2001. And you can see some of these domains. But, and you can see today in Bing, there's several domains being developed. So it does take a while to make this thing web scale. Although the reason we could not do web scale 10 years ago was mostly a business reason. The VCs did not believe for a 4-year period that you can make money doing advertisements. So they didn't want to fund web search companies until Google showed in 2004 that you can actually succeed. Anyway, so the idea was that we could do facilitate search behind each of these topics or models, domains. You had models. And for the models, you had a lot of entity bases and relationships. So you had learned a lot of facts. I'll show you how. And then you can interconnect all kinds of information. You can convert unstructured data on the web pages into structured data and have the metadata, and then you can support search. So when you type in, for example, Commerce One, that company has been purchased now, but at that point, these are 10 years old slide. It will know that this is a company in this particular sector, these are the competitions, these are the people, executives working on this company, these are technologies that it works on, these are the products and services it has. And when you, for example, type in David Duval, it would know that it is a golfer, and so it will use the golf-related knowledge base and give you golf-related contextual information, the relationships in that. And instead, if you type Robert Duvall, it will know that this is a movie actor, and there will be movie-related things, and all kinds of related information will show up, and so on and so forth. And broadly speaking, this was the architecture that was implemented then. On the top right, you see development of ontologies or domain models. And there was schematic information like schema.org you can see today, and basically ways to constantly keep those knowledge bases up to date. So there are focus extractor going to MLB.com, Major League Baseball, and get the baseball information, or NFL.com, or would go to some financial sites and get the financial information, and they would populate each of the domain. They will continuously run at different periods of time depending upon the domain, how frequently the things change. For example, for the baseball or basketball, things will change a couple of times in the season. But for financial data, companies that are publicly traded will change every day. And so the knowledge base will be kept up to date. And then the whole thing was about applying that knowledge to improve lexical, NLP, and other techniques, machine learning techniques for better information extraction, leading to semantic annotation or semantic metadata extraction that will improve semantic search and other applications. So let's fast forward 10 years. And now what we do is that we deal with a whole bunch of data. We deal with structured and semi-structured data. We deal with textual data, informal data, particularly the social data that I'll talk about. We deal with a whole bunch of multimedia data, sensor data, and so on and so forth. And for each of these, we use the domain model to extract the metadata, and then from that we can do, connect all this data and make a relationship between them, and then you can do more intelligent search, integration, analysis, discovery, situational, and all these kind of applications. For the little time I've chosen to focus on social data. So we know the massive increase in the use of social data, you see Egypt protest. You are aware of that. You see Japan. You can see the Japan tsunami and earthquake, and see the use of social data in that context. In fact, we just got an NSF project funded that involves collaboration with the social scientists and computer scientists in trying to see how people use, coordinate during emergency time using social networks. And you may have daily events. It does not have to be one of a kind event. You may have traffic jam, and there you have sensor networks, and you have tweets. Collectively, they allow you to understand the situation. Why is there a traffic jam? So we call this topic that of citizen sensing. Citizens meaning citizens of internet, sensing all the time with human in the loop sensing, collecting the information, observing, reporting. Then we analyze, disseminate, collaborate, and so on and so forth, using text, video, audio, sensor devices, and so on and so forth. So, and two other main factors for that are mobile devices. And again, I think we have talked about this yesterday. Billion plus internet connections, 500K plus mobile applications, huge amount of SMS also, not just Twitter and other things. And of course, the social media. 750 million plus users on Facebook, how fast Google Plus is developing, and so on and so forth. 1 billion plus tweets a week, right? A lot of data that we can use, analyze, and understand from. So let's look at one application. This is live application. You can go to Twitris, search for Twitris on any web search engine, and go to the system and look at it now. But this Twitris gives you information on what, where, what people are, and when. And it also is working towards socio-cultural and behavioral studies of the thing. So here is the quick look of Twitris. You can look at the variety of topics. For example, one of the topic that you can find is Mumbai blast that occurred last week, and you can see the analysis of that. Or you can find the dates on which the variety of discussions happen, right? So, and you can see the spatial marker. So the topics or discussions coming out of Afghanistan on Bin Laden death versus that coming out of US. And you can get these sort of n-gram-based summaries. Behind that, there is more things happening. For example, understanding of entities and such, I'll show you later on. You can see related tweets. You can see reference to the news articles that are happening on those particular topics that you chose. So you can click on any of those key phrases there, and you can see corresponding news items. You can see Wikipedia entries and so forth. You can see images and videos. You can see traffic, and you can see the sentiment analysis for the themes like that. So all of these things can be done on large number of data. Of course, I have only a few computers. Just recently, we have just started in the process of using Azure to do some of these textual analysis, which is very consuming, computationally challenging for a set of computers that I have. Anyway, some of the interesting things you can do this from this is that what are people talking about on the same topic or on different days, right? So in United States itself, on the Bin Laden death, on first day people were talking about the hideout in Abbottabad, and on the 2 days later they were talking about virus hack attack that people are using Bin Laden and sending the messages, and that they are sending virus. But you can also talk about what people are talking on the same day in different parts of the world. So social perceptions. So for example, in Egypt, the government talks about US killing Bin Laden as also a form of violence, while in India, for example, there is a preoccupation with Pakistan-India thing, and you can see that signal coming up there about. So these are very interesting things you can learn from the analysis of social media. In all of these things, what I will try to show in the short time I have, the use of social domain models and semantics. Among the things that we do is this content analysis, user community engagement, how communities forms during a product launch, what factors can attract users to engage these communities. When is it likely? How can I? What are the factors that I can control by which users will be tempted to join the discussion or form a community, or why would users leave the community? Many things of that nature you can discuss there. So we have a people content network analysis framework. Won't have time to go into that, but there are a whole bunch of features that you, for example, can analyze and learn from that. Again, quite too many to discuss here, but which of these features are important? And just to see you the top level result is that we found that the content aspect played very important role. If you are working in this area, you know that there's huge amount of work in network analysis, right? In social media network analysis, that's a lot of work. Interestingly, we find that the content feature plays extremely important role. And now if that is the case, how do we understand the content in this kind of context? So you can mine the user profile and user interest and have understanding of user types. That helps you understand the people kind of aspects of it. Or you can dynamically create domain model for the events and start understanding about what people are talking about by using the model that is created on the fly. You can use background knowledges of Wikipedia and link open data and many other things like that. For example, look at this particular post or a tweet or whatever, this new Merry Christmas tune, so good. Now, how do you know which Merry Christmas tune you are talking about? Well, it is very hard to understand just by using any natural language processing or textual analysis. But if you have music brains, you at least know that there are 60 songs, and this is one of those 60. Then, of course, you can do a lot more than that. You can use the key of new and tune, and then that helps you decide which are the few ones that are likely to be from among the 60. So good is also a song. Is this a cultural expression here, cultural entity, or an entity, particularly song here? These are the interesting information things that you can do, in my view, only if you can combine the background knowledge. And the interesting thing is that in most of the things that I'll talk about, this kind of knowledge exists or can be very quickly created. One of the interesting set of applications are real-time applications. Ushahidi, this is used extensively worldwide for disaster management. Or in real-time market analysis, brand tracking, Twarkle is a system that we have developed, movie reviews. You take an example of brand tracking and give me all the people that have said negative things about Connect. And from where? So how can we do that? Well, what we can do is that we can take the streaming data and we can do structured analysis on the data. And we can use background knowledge to improve that structured analysis of the data. So I can do Sparkle query on the streaming social data, like Twitter data, to analyze these kind of things. For example, so there is an architecture like this. Again, you can Google or Bing Twarkle and get a lot more information about that. I won't go into detail. It uses pubs of hubbub. But then you can formulate queries like this. Give me a stream of locations where Connect is being mentioned now. So in this case, applying structured analysis on unstructured data with the use of model, what does Connect mean? That makes all these things possible. Or give me all the people that have said negative things about Connect. Again, you have to use unstructured data. You have to do sentiment analysis. Sometimes you do intentional analysis. And then you can do queries along this line. And you can do this in real time. So let me show you some very interesting examples, some emerging research I call continuous semantics. And in this particular case, what we are trying to do is we are dealing with some of the events that evolve over the period of time. And in these events, there are things that occur that you are not aware of ahead of the time. You take the example of Iran elections. And there was a very major sub-event there called Kno.e.sis killing. There was a young woman that got killed, and that was a very major worldwide event. And before this event occurred, nobody knew about this Kno.e.sis per se. And what does it mean? What does it mean to the this particular event like Iran elections and what is happening in Iran? And so how do you identify that this is an interesting and emerging concept? And how do you use that knowledge to further understand the content and discussions that is going on? So, how do you, so in that context, what we do here is that we take the stream of the data, maybe Twitter stream, And then we do the analysis. I showed you Twitris earlier, so you can have the clouds like that. And using those terms or key phrases, we supply to a tool that we have called Dozer, and that creates this model on the fly. So for example, in analyzing Egypt Revolution 2 related tweets, we have model that was created from Wikipedia, and that tells me that Heliopolis is a suburb of Cairo. This then helps me a lot more in understanding the things. For example, on 29th of January, there was discussion about million-person-man march. On January 30th, there was the million-person march. We started with Tahrir Square and went to the suburbs of Cairo. And knowledge of which are the suburbs of the Cairo and their occurrences in the discussions helps me understand what happened, and helps me understand this event at much higher level of granularity. So let me show you the example. Though you'll see the some of the messages on particular date. You will see some of the key phrases that were extracted, and then you will see the models being evolved. So here, for example, this model here you see that Ahmadinejad and Musavi were extracted. They are politicians. They are from opposite party. All this is extracted. Then it's applied to understand that information, and then you can go on with saying that there is a university here, and then there is for Azadi Square, and that Azadi Square, is a suburb of, is a part of Tehran, for example. These things then help you understand what the discussion or discourse going on. Other related things are like sentiment analysis, one of the interesting, important, and challenging tasks. And here, for example, you look at long river. Well, there's no sentiment. You look long battery life, there is a positive sentiment. You look at long time for downloading, that's a negative sentiment. So these are domain or topic specific cues. Or it may be context specific. For example, you may say must watch a movie today. There's no sentiment to that, but this movie is a must see. That's a positive sentiment, right? So how do you get sense of those kind of stuff? There are of course other challenges like abbreviation, misspelling, slang. You can use Urban Dictionary for some of these. So in this particular case, oops, something happened, and I passed this. Oh, there's one slide that just simply disappeared. Well, that was a pretty important slide, but I'll tell you what the slide was about. So the slide was showing you that you can use music brains, or you can use link open data, you can use Wikipedia to understand the entities that are appropriate, that are mentioned in the text like that. Additionally, you can use Urban Dictionary. And then suppose you have use of word wicked. Well, the interesting thing is that the word wicked has multiple connotations, and in fact, some of the connotations are geographically sensitive. So, for example, the interpretation of wicked in US and UK is different than one in France, and the nuances and the sentiment cues are somewhat different. So, using these kind of things, you can make better sense out of things, and so you can use variety of models behind the scene to understand different aspects of the semantics in this case. And so that particular slide, in fact, somehow it shows a blank here, shows how those kind of things we can find. And finally, what's happening here is that there is a massive growth of information from documents to Web 2.0 content to now a lot more real-time data. And much of the data now is sensor data. So we saw recently a growth huge growth in social data. In the next thing, now there are 40 billion sensors already out there. 40 billion mobile sensors are already deployed, and they are growing at much faster rate. Majority of the sensors are on the internet and web, right? So they create data. Some of them are complementary data. How do you make sense out of this? So this creates massive amount of data. I care less whether the temperature is 32.4 degree or 32.8 degree. I care whether the temperature is too severe, or whether I should take a jacket today, my heavy coat or light coat, or whether roads are icy. In a flight, you can generate 240 terabyte of data. How much of that is interesting to human decision making? Pilot cares about only very little, few cues from this, and the ground queue after the plane has landed only cares about some of the other aspects, right? What you need is human abstraction, and what you need here is semantic scalability, right? You have huge amount of sensor data, huge amount of social data. You need semantic scalability. Yesterday there was a slide saying our capacity to understand has not gone up, right? So how do you convert from this huge amount of data into abstractions? And so I have an application that will alert me when some things are, I should be alert about weather. But I don't again care about the particular temperature. I care about what is the thing that what are the actions that I might need to take because of the weather. So a lot of data are not all that important. You need to be able to understand that. And so this shows you some experiments here where you have raw data, you have abstractions. Abstractions are a lot more manageable than the raw data. And then here's an example of traffic application where sensor data are capturing how much cars are passing. But then you want to figure out what happened. Why is there traffic jam, right? And there are tweets. People are talking about that. So here, in this case, an example is that you take all this data and you have domain models about traffic ontology, but you also would need sensor ontology. You'll need ontology on time and location. These are very important because the moment I annotate something with the time, I can then reason about something before time. I can say it is 10 minutes. I can only look at the information that is 10 minutes or half an hour before my, before it is time for me to drive home, right? Or this is nearby, or is it on my path? This kind of decision can be only done once you map the specific geographic location into in a spatial ontology, for example. And then you can do, in this particular case, we do stratified reasoning. So we will look for example, normal events like rush hour traffic. Then we'll start looking for planned event like road repair. And then we'll start looking like car accidents, some impromptu events, unexpected events that might have occurred. But this kind of reasoning is now being made possible because we take all this kind of social and sensor data, we annotate them using variety of domain models, and then we are able to then do all these applications. So I end my talk with 3 take-home messages. The first is that the amount of citizen sensing and, of course, some end machine sensing data is huge, varied, and growing very rapidly. Search and SIF won't work. Number 2, semantics play a key role in referring meaning behind all this data. So, for example, you want to go from keywords to entities to relationship to event understanding, and you need to go from raw data to human abstractions. And number 3, fortunately, we have wide variety of semantic models and knowledge bases, vocabularies, social dictionaries, community-created structured knowledges, things like Urban Dictionary, domain-specific database, dynamically created models, ontologies, all these things which are powering semantic solutions. This can lead to semantic scalability.
Right, thank you. That was a huge breadth of topics and applications.
Fast
we can
talking.
take one. We can take one question while we transition. I'll ask you a question while we transition. So a lot of what you present, how much is mashups of data already existing, and how much is you creating the models, and how much was created?
Data. Mm-hmm. So for example, we have whitelisted 20 computers on Twitris team and getting the data that way. The user is a real tool, and it is actually, so you can use that. It's there, being open source. The sensor data, there are many demos of sensor data. Again, we have, for example, 20,000 weather sensor data coming in, and we are doing semantic sensor web applications on that. So what I showed you are more as Twitris is, you can play with it now and see what it is doing. Again, Twitris is only limited in scope just because we don't have the computers that Microsoft and Google has. If we had it, we could also scale.
Okay, let's thank our speaker again.